So today is a day for another one of my amazing flat earth videos. I'm going to prove to you guys today that you are the center of the universe. And so am I. And so is everybody from their own perspective. But we truly are the center. And I'm going to show you that the heavenly bodies move around you. There's no other way to explain it because of the way that they move. It doesn't work on a globe Earth model or a flat Earth model. I'm going to show you why. Here's a very cool video that a guy did. So what it is this wheel here represents our movement around the Earth as it rotates. Well, this way. So people are going to say, well, that's a wheel. It's not a globe. Doesn't matter. Same thing. You're on the outer edge of it, and pretend it's a globe. Make a ball out of it. Doesn't change anything. If you're on the edge, you're traveling this way, and that's what's supposed to make it look like a stationary sun is rising, going to high noon and then sunset. Because I guess if you come around here, from back here, you ride the Earth to this point, you're going to see morning, sunrise, and then as you come around, you got midday, and then you move away around the circle, around the globe. It's spinning. The sun appears to set. But what's really happening is that you're just on a spinning basketball, and as it turns you away from the sun, it just looks like it's set, but it really never moved. Only you're moving. But what I like is this guy made such a cool animation that shows you if that's what is really happening, the sun could not move at a constant speed. Yet we know it moves at 15 degrees per hour across our sky relative to us. So we're moving, but it appears the sun moves. So that's a constant speed. So just watch this animation. So this yellow line here will represent like a constant movement, and it'll go from here to here at a constant speed, and then this green line and the red line, I forget which one it is, it shows you the motion this guy takes on the ride around the Earth. And what it'll show you is that if that's how he's getting from here to here, we're moving from here to here, but around a circle. When you compare those two motions side by side, you see that one is constant and one is not. It cannot ever be. Just watch this. Kind of cool when he talks.
And now, your motion is across the face of the sun. It would speed up. You'd catch up at 12 o'clock, and now your speed would still be faster. And now, as you move away from the sun, your speed would slow down. So time itself, if you were living on a spinning ball, would be an issue.
Time itself,
the simple fact,
would be, if we're living on a spinning ball, would be an issue, because time moves at a steady pace, so we can track the motion of things around us. But if the motion is happening because we are riding around this ball, he just showed you that the motion of the sun cannot be constant, like this yellow line was. They move at different rates of speed. They get from point A to point B at the same time, but one line travels at a constant speed, the other one does not. It's impossible. So I'm going to show you that more clearly. There's this. So look at like here's like a globe, the Earth. This is, oh, shoosh, I hope I didn't move it. I moved it. Oh, well. I can still do it. We'll go here. This is a real video of Earth from space. You know, it's like amazing. They got a spaceship out there. Oh, come on, man. You're going to load me up like that? I'll go back to that. It's not working. I don't know why it's not working. Let's go over here. It's retarded.
Hey, have you seen these new rings? They're made of silicone, and they're called groove rings. Cool, right? Well, you want to know why NFL...
All right, here we go. So let's pick a spot. Like, freak, man. What is the problem here? Okay. So let's pick this spot right here. I'll pick this spot. Where's my thing? Oh, yeah. And let's go with this little spot right here. I'll track it with the mouse. So I'd say from here to here. Wait. Oh, went away. Maybe it's not a good spot. This one. This cloud right here. From here to here. It's a little more. Let's go to the middle. From here to here to there is same as from here to here. This video is not working out good. Anyway, I won't do it like that. Let's just follow this. So if you track this, track it, you're going to get from here to here across the middle fairly quickly. I can count and time it, but so let's say now then go from here to here. It's going to take longer to travel. You go around because you see that. So I started here. That little cloud, as I tracked it, to go from here to here across the middle part of the ball was a lot faster than from here to here. So if it looks like that from out here in space looking down at Earth, it's going to look the same from there looking up at us. As long as they can see us. Let's say we're on the sun and we've got a telescope, we're watching the Earth turn. That effect that we see, the people here are going to have the same effect looking up at us if we're standing on the sun. Or let's say we are the sun. If they're looking at the sun, it's going to move quicker at midday and slower at sunset or sunrise because of the nature of the sphere, the way that it turns, and the way things look if you're riding around a sphere, because you're going from point A to point B, but you're not going in a straight line. You're going around. So you're coming forward, then across, then away. See another picture. What's this? Oh, this is kind of crazy. Watch this. Dude went flying. Anyway, I was looking for things spinning to show how stuff is faster in the middle than on the side. You can't really see it there because it's going too fast. But these dudes put a motorcycle tire up against a merry-go-round, little kids playground game, and then the dudes are on there, and man, they go flying. I don't see how people are. I think one guy that commented said people are dying and breaking their necks and stuff. It looks like it. I mean, look how this dude flew off. Look at that. Damn. But anyway, by the way, what's keeping us from flying off like that? If we're spinning 1,000 miles an hour, yeah, I know it's a lot bigger and relatively slower, but what is gravity, like a rope that just keeps you there You can't, no matter what, you can't break it. It just keeps everything like perfectly where it's supposed to be. It doesn't make sense, man. But this video is about something else. So here's a diagram somebody sent me once. She wanted to prove that the Earth moves at 15 degrees per hour. So if you had like a dot in the middle of this diagram and drew lines out to each one of these guys, it would represent the movement, the 15-degree movement. So see, it's like, she goes, see, it shows how, there's just a constant movement. You go around and everything's works out fine. But it doesn't, because this, a circle can move at a constant speed if we're up here looking down at it. You're looking down at like a clock. You're watching the hands of a clock going around in a circle. Sure, they're going to move constant. But that's not what's happening. If we are this guy and we are looking through his eyes, we are standing here, we are looking through our own eyes, the experience is going to be different than if I'm up here looking down at a circle that's spinning this way. See, it's going to be more like, okay, so let's say you have this disc. Again, this shows the 15 degrees motion of the sun. If this is morning and this is night, this would be daytime, and the movements of the sun. And it all works like it shows the constant movement of the sun. But the problem is that so I kind of drew this. So this up here could be like night. Let's pretend that's night. Let's pretend this is a globe. This is nighttime. The day is here. But what's happening? So the lines, they're not 15 degrees. They're probably like 20 degrees. Just easier to draw. Those lines are equally spaced. But the problem is, if you turn it this way, which is what we're dealing with, you see the lines towards the middle are further apart than the ones on the edges. Like if I turn this edge, like if nighttime is, if night is up there and day is down here, it's hard to point, but this edge here is where daybreak would be, from day to night. And you just don't even see it anymore because the space shrinks. But it takes the same amount of time to travel through each of these sections. You see what I'm saying? Let's say it takes 1 hour to move through each of those sections. It works fine if it's turning like this, like a clock, or like this way, like a clock. Either way, it doesn't matter. But again, that's not what's happening. We are on the spinning ball. And as you see the lines from the side, when it turns this way, the motion can't be constant from point A to point B, because there's a bigger space, like I said, between the ones in the center opposed to the ones to the side, because you're traveling towards and then away from. So you spend the same amount of time covering less ground on the edges than you do in the center. And then some guys will say, well, but it's because it's so far away that the difference just goes away. At what distance does this rule become void, nil? Like, how far away do you need to get so that if you're traveling from here to here around in a circle, it just becomes a constant movement, as though you're just traveling like from here to here in a straight line. At what distance does that? At 1,000,000 miles? It doesn't matter anymore? It just, Sorry guys, that doesn't work. It never changes, no matter how far you are. As long as you can see it, it's going to move quicker from here to here than it does from here to here, or from here to here. There's just no way around that. You could be a moron and argue about it, but you're wrong. You're either a liar and stubborn, or you're just dumb. Have someone smart explain it to you, man. I can't explain it any better than this. See what's next. Oh, so like again, like this race. If you're watching race cars move past you,
Eyesight for fourth into.
yeah. See, they zoom by you quicker when they're traveling past you. I don't want that part here. Here. Oh well, you know what I'm saying. I don't know where that part went. Oh well. But the idea is, what I'm trying to say is, when they zoom past you quicker than they appear to be moving when they're moving away from you around the track or coming towards you. What's next? Then this is kind of cool. This is why it doesn't work on the flat earth either. Watch this video. So here he's just showing how the heavenly bodies are moving above the flat earth. But it's the same problem. If that was happening, watch like the sun. Like, oh man, where's my mouse? Here. See the sun? See how it's coming towards you? Not much lateral motion. And then as it moves away, he kind of went away from that. But see, it would be the same problem like on a racetrack. I can go back and see it. But like, like if you're standing here, they whiz by you, and then it's going to appear to slow down as it's further from you, and slow when it's coming towards you. But when it whizzes by, it's quicker. So again, you don't have a constant speed. It's a problem. Let's see. See, going by, and then watch the sun as it makes that turn back around. Slows down, or relative to you, it appears to slow down. That's the problem. It doesn't work on a flat Earth either. Let me see what's next. Well, that was it. So the thing is, what I'm trying to say is that everything around you, everything around me, everything around each person moves at a constant speed. The sun, no matter where you travel on the earth, take a plane to Australia, go to the North Pole, go to the equator, go to Europe, go to China, the sun is gonna rise, it's gonna move overhead, and it's gonna set, always at 15 degrees per hour. Whether you're on a ball Earth or a flat Earth, that doesn't work. It just doesn't work. I showed you why it doesn't work on a globe, and you see the same problem on a flat Earth. If the sun, let's say this is the horizon. Forget these planets. Let's say this sun is rising on a flat Earth. Make it bigger. The sun is rising. It would like move up. It would just come slowly, like zoom. Like it would be the same thing. It wouldn't work. But only if you're in the middle and everything is spinning around you, it all makes sense. And that's what's happening. You are the apple of God's eye. He's watching. Everyone above us is watching each one of us as though we're the only ones in the universe that exist and matter. Your life, what you do, you're the middle. You are the center of the universe, and so am I. So how are we going to live?